Picture getting an unexpected visitor, but not from across the street or an old friend from out of town. I'm talking about a traveler from another star system, cruising through the void for billions of years just to show up here, in our cosmic backyard. And not just any visitor. 3I/Atlas might be the most mysterious interstellar messenger we've ever seen, carrying secrets that could rewrite what we think we know about the universe. Science is fascinated and stumped. This thing has been defying expectations since the moment it arrived. An unusual path, signs of activity way earlier than expected, and a size nobody can quite pin down. It's like it's playing a game of clues with us, revealing just enough to keep us hooked, but holding back the rest like a master of suspense. And here's the kicker. This might be our one and only chance to see it. Soon, it'll vanish back into deep space, taking with it answers we may never get. Until then, every observation is a race against time. So, who exactly is this messenger? And what's it really here to tell us? The ancient messenger, a cosmic relic in transit. Imagine a lonely traveler drifting through the emptiness of space for billions of years. No rush, no map, just following the silent dance of the stars. This cosmic relic, we call 3I/Atlas, is like a messenger from a time when our sun didn't even exist yet. If we could hold it in our hands, we'd be touching fragments of long-lost worlds, pieces of the dust that built entire civilizations far away, in some forgotten corner of the galaxy. It's like finding a letter written before Earth even knew how to write. Now think about this. How many stories can fit inside a block of ice and rock that's seen more than any living thing ever could? By studying this cosmic relic, scientists are trying to uncover its origin, like flipping through the pages of an ancient diary, where each page is a layer of space dust. It's cosmic archaeology, except, unlike earthly ruins, this piece hasn't been touched by human hands until now. Looking at it is like looking straight into the galaxy's past, into secrets only time has the key to. And the strangest part? Even while carrying memories this ancient, the messenger doesn't show up screaming for attention. It appears quietly, almost shy, yet with an undeniable pull, like a mysterious guest at a party who never says their name, but leaves you wondering, where did they come from? What path did they take? And of course, how many other stories, maybe even stranger ones, are already on their way toward our starry horizon? From the south to infinity, an unexpected origin. When 3I/Atlas was first spotted, most people assumed it was coming from the same predictable direction as other interstellar visitors. But nope, this cosmic relic showed up from the southern celestial hemisphere, almost like a traveler taking a hidden shortcut to avoid the busy roads. This unexpected origin caught astronomers off guard. Most of our best space surveillance is pointed toward the northern skies. It's like waiting for a guest at your front door, only for them to sneak in through the kitchen. That backstage entrance raises a pretty intriguing question. How many other cosmic messengers might have passed through southern skies without us noticing? Every interstellar particle carries clues about faraway solar systems, and missing one is like losing a crucial piece of evidence in a mystery case. Maybe it's time to rethink our spacewatch strategy and widen our gaze before more of these visitors slip past unseen. And the coolest part? There might be other travelers right now, taking the same unusual route, sliding through the dark like ghost ships on a cosmic ocean. Invisible, silent, but loaded with secrets that could turn our entire view of the universe upside down. Pint-sized or giant, the nucleus enigma. When the first size estimates for 3I/Atlas came out, it sounded simple. Measure it, jot it down, move on. But the more they looked, the more the numbers became a puzzle. Hubble pegged it at somewhere between 0.32 and 5.6 kilometers, like trying to guess someone's height just by looking at their shadow. Meanwhile, the Vera Rubin Observatory suggested it could be up to 11 kilometers across, making this cosmic relic a true space fortress. The gap between those numbers had scientists scratching their heads. Is this a modest messenger or a silent giant? That question's more than just a tech detail. Size changes everything, from how much ice and dust it's carrying to how it interacts with sunlight and heat. It's like trying to understand a book story without knowing if it's a short pamphlet or a 1,000-page encyclopedia. That's why each estimate matters. And until there's a solid answer, 3i/Atlas keeps playing hide-and-seek with our telescopes, showing only what it wants. And maybe that's the fun of it, because deep down, it's not just about nailing down the exact measurement. It's about what the uncertainty reminds us, that even with all our tech, the universe still knows how to keep us in the dark. And maybe the next clue to solving this enigma isn't just in its size, but in the subtle signs it leaves scattered across space. The show of volatiles, water from afar. What really left scientists wide-eyed about 3i/Atlas wasn't just its origin or size, but the fact it started its show way earlier than expected. At over 3.5 astronomical units from the Sun, it was already releasing OH and water vapor, like a performer stepping on stage before the curtains even open. This cosmic relic, still far from intense heat, was already spilling its secrets into space, puzzling anyone who knows how these objects usually behave. The thing is, this early activity totally breaks the usual comet rulebook. Normally, volatiles only wake up closer to the Sun, when the heat's strong enough to turn ice into gas. But here, it's like watching a kettle whistle without the stove being on. It could mean 3i/Atlas has compounds that react to much lower temperatures, or that its surface, shaped by billions of years, has unique traits that let it release particles even in the deep freeze. That early awakening leaves us wondering, if it's already putting on a show from that far away, what's it going to do when it gets closer to the Sun? This might be the perfect time to ready our instruments, because the real performance could still be ahead. A more scientific and lighthearted take. In a world where headlines love to hype up alien mysteries, 3i/Atlas didn't escape some wild theories. Some even hinted this cosmic relic could be disguised alien tech, sent here with some secret purpose. But when the hype fog clears, the scientific interpretation paints a much more grounded picture. It's an interstellar comet, acting exactly like physics and chemistry say it should. It's like hearing juicy small-town gossip, fun to listen to, rarely true. The beauty is, science doesn't need over-the-top theories to make the story exciting. If anything, understanding its composition, movement, and even the volatiles it's throwing off is like cracking a mystery novel using real clues. It's like watching a detective movie where the ending blows your mind, not because they threw in an alien twist, but because all the answers were hidden in plain sight the whole time. Still, keeping a bit of humor in the mix is essential. After all, dealing with something that's traveled billions of years just to swing by takes patience and a healthy dose of curiosity. Each observation from 3i/Atlas reminds us, before we jump to wild conclusions, maybe we should enjoy the natural spectacle for what it is. And who knows, that might just prepare us for spotting something truly out of the ordinary when it comes along. Dancing with the particle, the comet's spin. Out in the silence of space, 3i/Atlas isn't just drifting, it's spinning, like a cosmic ballerina stuck in a step it's been repeating for ages. Its nucleus takes about 16 hours to complete a full rotation, and that's fascinating all on its own. That spin is the physical signature of this massive particle, revealing clues about its balance, structure, and even any collisions it might have had during its journey. It's like watching a spinning top and trying to guess how many times it's fallen and gotten back up. That constant rotation also affects how volatiles are released. If certain areas get more sunlight because of the spin, some spots can turn into cosmic geysers, while others stay frozen. It's like a tiny planet with its own seasons, except instead of blooming flowers, it's shooting gas and dust into the void. Understanding this choreography is key to predicting what it might do next. And honestly, there's something almost poetic about it. A traveler that's crossed unimaginable distances, surviving billions of years, still keeping its own rhythm, dancing for itself, whether anyone's watching or not. But what if that spin is changing right now, as the sun's heat works its way in? The next act in this dance might just surprise us. Cosmic rainbow, scientific beauty through filters. When telescopes captured 3I/Atlas in multicolor filters, the result was nothing short of magical, a rainbow floating in space. This cosmic relic, already mysterious because of its origin, got an extra splash of wonder. Each color in those images isn't just eye candy. It's a clue about composition, about which elements are present, and about how light interacts with its volatiles. It's like staring at a precious gemstone and realizing every sparkle tells part of its history. The science behind these images is just as fascinating as the view. Using filters is like putting on different glasses to spot details the naked eye could never catch. Reds might hint at organic material, blues at fine dust, greens at specific gases. It's almost like every particle the comet sheds has its own color ID card, forming a cosmic palette that astronomers decode like art experts analyzing ancient pigments. And here's the irony. In the deep black silence of space, suddenly there's a burst of color worthy of an impressionist painting. Maybe that's the universe's way of saying it doesn't just keep secrets. It knows how to reveal them in style. And who knows, the next time we look, 3I/Atlas might just show us a brand new pattern. The destination, a quick visit, packed with stories. 3I/Atlas isn't sticking around. Its hyperbolic path is a one-way ticket, slicing through the solar system at over 130,000 miles per hour. This cosmic relic came, put on its show, and will soon slip back into the depths. It's like a touring musician doing a single concert in your town before heading off to the next city. But while it's here, it's giving us enough material to study for years. That short encounter is precious because every detail, from its size to the way its volatiles behave, is a puzzle piece in our bigger understanding of interstellar objects. Each observation gives us hints about its origin, about the story it carries, and about how these visitors behave. It's like interviewing a traveler who's crossed lands no one else has seen, and trying to soak up every detail before they vanish over the horizon. And maybe that's why its fleeting presence keeps us hooked. We know it's leaving, but we can't be sure what its last act will be. Maybe it'll treat us to a light show, or shed rare particles as a kind of farewell gift. And maybe the next interstellar visitor is already on its way. Now that you know the story of 3I/Atlas, it's hard not to wonder, how many other messengers like it have passed us by without us even noticing? Could there be another interstellar traveler out there right now, slipping through the sky unseen, carrying clues about the origin of worlds we'll never visit? The most amazing thing about this short visit is that it proves something simple. The universe still has so much to teach us, and it's not waiting for us to be ready. The question is, are we going to just watch, or are we going to prepare for the next visitor? If you want to keep exploring these cosmic mysteries with me, hit that subscribe button, turn on notifications, and join the adventure. Because who knows, the next big space enigma might already be on its way.